الرحمن الرحيم. In this topic, we are going to find the derivatives of the trigonometric functions. Trigonometric functions mean the sine, cosine, tangent, cotangent, secant, and cosecant. So let's start giving the derivatives of these trigonometric functions, and we know we have six trigonometric functions. Number one, we have sine x. Number two, cosine x. Number three, tangent. 4, we have cotangent. 5, secant. And number 6 is the cosecant. The derivative of these functions, d by dx of sine x, is equal to the derivative of the sine is equal to cosine. I need to go with the proofs of this one. Derivative of sine is equal to cosine. Derivative of cosine is minus sine. Derivative of the tangent is equal to secant square x. Derivative of the cotangent is minus cosecant. Derivative of secant is equal to tangent multiplied by secant. And derivative of cosecant is equal to minus cotangent multiplied by cosecant of x. So cosecant is cosecant square, or the cotangent is minus cosecant square. These are the derivatives of the trigonometric function with one remark. Say that any function, we can say that any function start with c, there is negative. This is just to make it easier to memorize. Cotangent will give me minus cosecant square. Cosecant is minus cotangent x cosecant, and cosine is minus sine. So any function start with the letter c will give me negative derivative. So these are the trigonometric or the derivatives of the trigonometric functions. Now we can solve some examples containing different type of techniques, either maybe quotient, maybe product, maybe power. Let's see that one now. Example, let's find the derivative. Find the derivative of the following. Number 1, y equal to minus 4x squared multiplied by cosecant of x. In this example, you can see that I have product of two functions. It is a product of two functions. I have two functions, minus 4x squared multiplied by another one, which is cosecant of x. And to find the derivative, since it is multiplication of two functions, I need to apply the product rule. So by the product rule, which is the derivative is f prime multiplied by g plus g prime multiplied by f. Y prime, the derivative of this function is equal to, it is the derivative of the first function, which is minus 4x squared. The derivative of minus 4x squared is equal to minus 8x multiplied by g. G is cosecant of x plus, now the derivative of the cosecant, the other function, that is minus cotangent of x multiplied by cosecant x multiplied by the first function f, which is minus 4x squared. So I wrote the product as g prime multiplied by f prime. It is g prime multiplied by f prime g plus g prime f. So this can be written as minus 8x cosecant, minus with minus will be plus, it is plus 4x squared multiplied by cotangent of x multiplied by cosecant of x. So this is the derivative of this function using the product rule. Let me take another example. Number 2. Y equal to secant of x plus 3 tangent. Now the derivative of this function y prime is equal to the derivative of secant x is equal to secant of x multiplied by tangent, or tangent multiplied by secant, they are the same, plus derivative of 3 tangent. 3 is constant, so I will keep it as it is, 3, applying the constant multiple rule, 3, and the derivative of the tangent is equal to secant square of x. Third example, y equal to sine x multiplied by cosine of x. Again, I need to apply the product rule for this one. The derivative y prime is equal to, by product rule, that is f prime g plus g prime f. The derivative of sine, the first one, is cosine, multiplied by g, which is cosine of x, plus, now derivative of the second one, which is this one, derivative of cosine is equal to minus sine, multiplied by the first function, which is sine x. So this is equal to cosine square x minus sine square of x, or just simply can be written as cosine 2x. This is the one of the identities of the trigonometric function, or double angle. Cosine square minus sine square equal to cosine 2x. So the derivative in this case is equal to cosine 2x. Take one more. Number 4. y equal to secant of x divided by 1 plus tangent. And we need to find the derivative. And this is a rational function. So we need to apply the quotient rule using the quotient rule. That is f prime g minus g prime f divided by g squared. So the derivative of this function y prime equal to the denominator square, which is 1 plus tangent square. Now the derivative of the numerator secant x equal to tangent multiplied by secant x multiplied by the denominator, which is 1 plus tangent. So we are done from the first part of the quotient, which is this one, minus the derivative of the denominator, which is 1 plus tangent. The derivative of 1 is equal to 0. Tangent will give me secant square multiplied by the numerator, which is secant of x. So this is the derivative, y prime equal tangent multiplied by secant. This is the derivative of the numerator multiplied by 1 plus tangent x. This is the denominator minus the derivative of the denominator, which is secant square multiplied by the numerator divided by the denominator square. We apply the quotient rule. So this is the derivative. One more. Y prime equal to square root of x divided by sine of x plus cosine of x. So this is y, not y prime, this is y. And I need to find the derivative. So the derivative in this case will be y prime is equal to, again, apply the quotient rule. It will be the denominator square, which is sine x plus cosine x square. For the numerator, the derivative of square root of x is 1 over 2 square root of x multiplied by the denominator, which is sine x plus cosine minus. Now derivative of the denominator, that will be sine will give me cosine x. Derivative of cosine is minus sine x. All of these multiplied by the numerator, which is square root of x. So this is the derivative of this function y equal to square root of x divided by sine x plus cosine x. What we did, we just applied the quotient rule. F prime multiplied by g minus g prime multiplied by f divided by g square. And we got this derivative.